chart and toolbook has made rapid prototyping possible. Professionals and students in many cases prefer to develop, that is, design and produce, a prototype of a more elaborate interactive multimedia program with these authoring systems instead of designing a program in an analog storyboard first and then producing it on a computer. As media computers and their related software mature, it is conceivable that the concept of rapid prototyping will be extended to encompass the design and production of instructional materials as an integrated activity instead of two separate processes. A key factor to this integration, however, is the degree to which the designer-producer can use multimedia workstations to interact with the learner for assessing needs, defining objectives, deciding instructional strategies, and other instructional design, evaluation, and management activities. Now we turn to virtuality. Fiber optic lines with almost unlimited bandwidth and new telecommunications protocols such as Integrated Services Digital Network, or ISDN, extend the digital revolution from multimedia representation to multimedia telecommunications. While existing twisted pair copper wire telephone lines can be used to transmit and receive integrated voice and data, the ideal medium for combined video, voice, and data telecommunications is the optical fiber. The multimedia desktop workstation, complemented with an integrated telecommunication system, provides a bidirectional, interactive virtual space in which teachers and students can see each other, talk to each other, and share information in any mode. In more advanced workstations, teachers and students can access libraries, databases, and information services located in different parts of the world. Moreover, on such workstations, intelligent tutoring programs provide just-in-time help to users. The fusion of multimedia desktop workstations with integrated telecommunication systems has accentuated the arbitrary distinction between distance education and conventional education. Moore introduced the concept of transactional distance, in which distance is defined in terms of the ability of an instructional system to respond to a student's need regardless of physical proximity of the teacher and the learner. Building on Moore's idea, I proposed the concept of virtual contiguity in distance education. Interaction in virtual space goes beyond the possibilities of so-called face-to-face interaction and can be defined in a dynamic relationship in teacher-learner communication. In this relationship, transactional distance is defined in terms of how much the instructional system allows for dialogue and to what extent it is structured. Therefore, in dynamic educational systems, distance between the teacher and the learner is defined by the level of structure and dialogue and not by the physical proximity of the educator with learners. Using this causal loop diagram, Rick Scherer, my research partner, and I, in a research study which we conducted last year, established a systemic and dynamic relationship between dialogue and structure. Our research showed that a learner and a teacher can vary the rate of dialogue and structure and control the level of transactional distance in a purposeful instructional setting. Ubiquity. The new media have brought a host of new teaching, learning, and training strategies into the realm of possibility. By eliminating time and geographic location as two major factors defining where and when education and training can take place, the new media has made learning possible at home and in the place of work, as well as in schools. Traditional schools are also changing as new technologies are gradually accepted in them. No longer the teacher is the sage on the stage, but a guide on the side. These changes are ushering a paradigm shift in teaching and learning. A quiet revolution is taking place, and as professionals involved in educational telecommunications, you are part of this revolution. I will spend the next few minutes on describing this change and its ramifications for education and training. Moving from education for a few to education for each. Print technology made education and learning available to the masses. Prior to print, education was a luxury affordable by a chosen few. With the advent of the printing press, books became widely available and millions of people gained access to information that was available only to a very few individuals. Later, radio and television further expanded educational opportunities for school-age children as well as for adults. The convergence of the computer with telecommunication networks promises to personalize learning. Individuals increasingly will be able to access instructional information that can be formatted and presented according to their prior knowledge on the subject matter and their goal and objective they wish to reach. Moving from teaching to learning. The new electronic media, for example, has shifted the emphasis from teaching to learning. Increasingly, information is becoming widely available on the internet in general and the World Wide Web in particular. In the past 2 years, thousands of web pages on every conceivable topic has appeared on the internet. In a world in which information is widely available, the role of the teacher or trainer changes from one who disseminates information to one who guides the students, assists them in finding the right sources of information, and helps them to analyze the information and synthesize it within the context that is meaningful to the learner. This revolutionary change in teaching, training, and learning has enabled administrators and educators to introduce a number of new strategies which have been either impossible or too costly before the marriage of telecommunication and computers. I will review these strategies in the next few minutes. First, computer-mediated conferencing, or CMC, enables learners to discuss subjects that interest them either in real time or asynchronously. In either case, CMC provides a rich forum for participants to share ideas, exchange new information, discuss their experience, and support each other. Real-time or synchronous computer-mediated conferencing provides immediacy and intimacy to those who participate. Contrary to the popular belief CMC is an intimate medium, users often report development of long-lasting relationships on the internet. Asynchronous CMC, as its name implies, does not provide for immediate communication, but allows participants ample time for reflection and writing thoughtful responses. Faculty and trainers who have used CMC invariably reported a marked improvement in the writing skills of their students. Computer-mediated communication has made other instructional and learning strategies possible. Through the use of software generally referred to as groupware, learners as well as their instructors can work in a collaborative environment. Collaborative learning strategies that require the participation of different players and stakeholders is becoming more and more desirable as the business environment changes. In today's business environment, managers and supervisors are compelled to do more with less resources. A key factor in increasing productivity with dwindling resources is creating a working condition in which the sum total of a group's output would be greater than the sum total of each individual's output in the same group. This requires a coordinated, streamlined, and a collaborative effort, which is possible now through the use of information systems. These new information systems provide equal access to what individuals need to know in order to do their work. The equal access to information not only brings more trust in the workplace, but also increases the output of the group, as everyone can play his or her part in the group with the knowledge and expertise of other group members available to him or her. This knowledge and expertise can be made available not only to someone's immediate group of collaborators, but to a business, industry, or an enterprise as a whole. Information systems called distributed expertise makes the knowledge and expertise of an individual available to those who may need it through a whole enterprise, regardless of how far the branches or satellite offices may be. Distributed expertise systems have merged learning and working together. No longer managers are compelled to sacrifice immediate productivity by sending their workers to training for the sake of increasing productivity later. Distributed expertise systems such as performance support systems bring learning to the factory floor or the desktop. Workers encountering a problem can access performance support systems such as just-in-time training to find an answer to a specific question regarding the task they are immediately involved in. By quickly accessing what one needs to know in the context that he or she needs to apply the information, learning and productivity increases, and the time to transfer the knowledge and implement it decreases. In other words, the knowledge base from which the information is received is directly related to the needs of the worker within the appropriate context of his or her work. In traditional training and education systems, transferring generic knowledge and information to a particular application is generally left to the learner. With the use of new technology, learning can be contextualized. The new information technologies are bound to change the process of learning and make it contextualized and problem-based as much as possible. In problem-based learning, knowledge needed to carry out certain cognitive or behavioral tasks has not been abstracted from specific applications. Knowledge and skill in carrying out certain cognitive or motor skills are taught within the context that they are usually applied. Problem-based learning is a more realistic and authentic learning environment than the traditional lecture-based teaching and learning. With the use of computers and telecommunication systems, students have databases which would allow them to conduct simulations of ordinary events or scientific concepts and processes is a powerful means of learning, as the learner gets to change the variables involved and see the result of this manipulation on the behavior of the entire system. You can conduct a scientific experiment, fly an aircraft, or operate surgical procedures on a simulated human body without leaving your computer workstation. This risk-free learning environment puts the learner in the position of control and allows him or her to formulate hypotheses and test them, as his or her learning schedule, prior knowledge, and aptitude would permit. Easy access to knowledge bases is not the only advantage of distributed learning systems. Through new telecommunication-based teaching learning systems, such as the ones set up by regional phone companies and local cable companies in the U.S., students in public schools, community colleges, and universities can take electronic field trips to businesses, industries, museums, zoos, parks, and other interesting locations without spending time in transit. For example, very often during these electronic field trips, students meet corporate executives, managers, experts, astronauts, zookeepers, physicians, nurses, and bankers, and interact with them in real time. An imaginative project conducted by the U.S. National Aeronautic and Space Administration, NASA, and the U.S. Navy allowed students in schools to manipulate a submarine in deep ocean levels and explore areas and depths otherwise impossible. Furthermore, students could ask questions from experts as they learned new things about the ocean. Such encounters with experts and professionals, of course, need not be limited to when electronic field trips take place. Meeting teachers and experts at a distance is another teaching and learning strategy which has become possible through the advent of computer and telecommunications systems. Several new strategies have emerged recently which take advantage of the new technologies. The simplest and most straightforward is perhaps the electronic office hour. Increasingly, faculty in colleges and universities use desktop teleconferencing systems, electronic mail, or other telecommunication-based systems to increase their access to students. Electronic office hours not only decrease traffic and time wasted in transit, it increases the probability of a direct meeting with the faculty. During such electronic meetings, the encounter may not be limited to a conversation. Strategies employed in so-called face-to-face education can also be implemented on electronic networks. For example, tutorial sessions and coaching in which hands-on training has been required have been successfully implemented by such pioneers in distance education as the British Open University for years. Such efforts and their success has effectively demonstrated that hands-on training and learning can take place at a distance when the instructor and the learner have access to simultaneous audio, video, and graphic communication. The myth that hands-on training cannot take place at a distance is therefore just a myth. Such strategies so far have been implemented among institutions of higher education, businesses, and industries. Only in experimental cases, institutional distance teaching and learning have been extended to homes via new telecommunications and computer technologies. Telecommuting from home for learning, teaching, and working is becoming a reality in many parts of the world as phone, cable, and satellite companies extend telecommunication services to homes which have been only available to businesses and educational institutions or only affordable by them. For example, recently in the U.S., regional phone companies have begun to make ISDN or Integrated Services Digital Networks available to homes. As you may recall from our first teleconference on the subject, ISDN is an international standard that changes your ordinary twisted pair copper telephone wire into a wide-band telecommunication line. Through ISDN, users can send and receive voice, video, text, and graphics at 128 kilobits per second. This is 4.5 times faster than the fastest modems available in the market now. What's more, ISDN is a seamless end-to-end digital telephony system connecting your computer to a digital network without the need for converting the output of the computer to an analog signal. This digital solution significantly increases the accuracy and speed of the signal in comparison to analog systems. Furthermore, since ISDN uses a telephone network that is already in place, it is much less costly than other telecommunication solutions. Therefore, ISDN has provided a viable and affordable alternative to homes who need increased bandwidth for telecommuting for educational or professional purposes. For many experts in the field, telecommuting is the wave of the future. ISDN, coupled with new personal data assistance and wireless telecommunication systems, are bound to make the ordinary household as sophisticated as in many corporate headquarters as far as networking and computing are concerned. However, critics of telecommuting are quick to remind us that it has some social consequences which may not be very obvious at the outset. For example, students and office workers who stay home to do their work invariably get involved in household chores, babysitting, frequent visits from neighbors, and other distractions which would lower their study time and their productivity as compared to doing the same kind of studying or working in school or in the office. Furthermore, office workers who stay home very often may be overlooked for a promotion, or students who stay home may lose valuable socialization, which is an important aspect of growing up. So the value of telecommuting for work or study should be assessed in relation to these social consequences. Extension of working and learning from school to the place of work and eventually to home, as well as its personalization through computer systems, has brought forward new models of learning that were overlooked in the past. In information-rich environments, such as the ones created by new communication and computer technologies, the emphasis has shifted from teaching to learning. Such information-rich environments are now possible as libraries are increasing their digital databases. Digital databases store information such as books, newspapers, magazines, scholarly journals, photographs, videos, maps, etc., in a form that can be accessed by client computers at a distance. Libraries like schools and institutions of higher education are expanding beyond their traditional boundaries and are reaching their patrons wherever they are and whenever they are ready to read. It is not far-fetched these days for a reader in one country to browse through a card catalog of a library located in another country. Connected to telecommunication networks, computer file servers holding the card catalog enable client computers to access them. The end user, therefore, has access to such information immediately. The use of these computer file servers have not been limited to traditional libraries. Book publishers, newspapers, magazines, and other information providers are making their information available on computer file servers. There are several projects worldwide that are transferring classical literature as well as photographs, videos, and other analog media into a digital format so they can be accessed through computer networks. Many universities are providing information, research results, and formal curriculum materials on computer file servers. As evidence from the dramatic explosion of the World Wide Web, such efforts in provision of information are only bound to grow. As I mentioned earlier, in this information-rich environment, the role of the teacher changes from a presenter of information to a guide. The educational paradigm is bound to shift from one of teaching to one of learning as schools, workplaces, and homes adopt new technologies, gain access to new information resources, and people find themselves in an information-rich environment. In the information-rich environment, teaching and learning is less a matter of filling up the mind of learner with facts and figures and more a matter of the learner gaining the ability to learn and being able to construct a knowledge base relevant to his or her life situation. One can argue that the paradigm shift from a behavioral model of learning to one of cognitive learning and the contemporary constructivism is due to the emergence of the information-rich environment. This change is reflected in the diagram you see on the screen. This is a continuum showing the education paradigm. At one end of the continuum, you see the behavioral model of learning indicated. In the middle, you see the cognitive model or information processing, and at the far right, there is the constructivist model. Each of these educational models imply a certain strategy for teaching and learning. These strategies correspond to the model of distance education presented earlier. Behaviorism. Traditionally, learning in education has been classified into three domains of cognitive, affective or attitudinal, and psychomotor. This classification, indicated by the American Psychological Association in the mid-1940s, was to facilitate testing and measurement by standardizing the terminology associated with human behavior. The classification was designed to be closely related to behaviorism, which became the prevailing school of thought at the time. Behaviorism was a theoretical view that primarily distinguished psychology from philosophy a century ago by objectifying the concept of learning in observable human behavior. It dominated the technology of education until the 1970s. B.F. Skinner championed the objectification of learning by demonstrating the efficacy of reinforcement in shaping the learner's behavior. Although psychologists began to pay more attention to cognition in the 1950s, behaviorism gained steady popularity in educational practice. Defining learning as observable and demonstrable objectives was useful to educators in designing instructional systems that directed the learner towards attainment of specific predetermined goals and the mastery of skills associated with those goals. Cognition and information. Although behaviorism was successful in providing a modern structure for educational practice, as well as in influencing the advent of learning machines and the rise of programmed instruction and computer-assisted instruction, it was woefully inadequate for explaining mental processes. Decision-making, problem-solving, and higher-order thinking, such as metacognition and creativity, could not be adequately explained in behavioral terms. Since the 1980s, there has been a tremendous growth in modeling the brain by computers as well as in conceptualizing the brain as a computer. Such modeling efforts, coupled with earlier mental models of the mind, have resulted in two general explanations for how the brain works. These models, in general, either compare the brain to a small but massive parallel processing computer or to a serial processor. In the former model, known as connectionism, the brain is described by a collection of simple but massively interconnected units, or neurons. In this model, learning and cognition must be carried out by connectionist-type processes. This model, however, does not have an explanation for the logical and linguistic functions of the brain. Such functions are attributed to the latter model, or the symbolic system theory, which views the brain's function as serial processing of symbols or symbol systems. In reconciling the two models, Leahy and Harris stated, "Yet we have learned physically different computational systems may implement the same programs. Therefore, it is possible that although the brain is a massively parallel computer like a connection machine, the human mind, in its rational aspects, is a serial processor of representations, especially when thought is conscious. The more automatic and unconscious or intuitive aspects of the human mind are connectionist in nature." Connectionist theories thus have a valuable role to play in being the vital interface between symbol system models of rational, rule-following thought and intuitive, non-linear, non-symbolic thought. Thus, cognitive psychology shifted the focus of educational practitioners from an empirical epistemology, which viewed knowledge acquisition in a simple stimulus-response reinforcement model, to a more subjective model, in which the learner participated in knowledge formation by relating new information to prior knowledge and by employing other processes such as reasoning, decision-making, and problem-solving. Constructivism: attitude, intentionality, and teleological behavior. Cognitive science, at least in its present stage of development, does not directly address the question of purposeful behavior and free will. It leaves the following question unanswered to a large degree. If all human behavior is dependent on prior knowledge and environmental stimuli, how can we explain independent action and autonomous human behavior? An adequate response to this question is important for a coherent theory of distance education, since learner autonomy is a cornerstone of adult learning theory, a concept that is increasingly extended to K-12 and other educational arenas. American pragmatist philosophers and psychologists of the late 19th and early 20th century have addressed the issue of independent human behavior and its ramifications for teaching and learning. Among them, the work of John Dewey and William James are outstanding. However, as Sattler has pointed out, a full analysis of Dewey's psychology of learning has not been accomplished yet. Furthermore, current general educational psychology textbooks make only a cursory reference to Dewey and mention James even less. It seems that the emerging paradigm of constructivism, as proposed by Jonasson and Lebeau, is either based on pragmatism or is greatly influenced by it. In other words, if constructivism is not a full implementation of pragmatism, it is the closest model of learning that has emerged from it so far. This model of learning views the learner as an independent agent who, in his or her experience of objects and events, encounters questions, formulates hypotheses, and seeks to resolve such questions by testing the hypotheses. Resolution of the problem both requires action and may result in action on the part of the learner, which affects his or her immediate environment, leading to new questions and new hypotheses. This experience is subjective and therefore highly individual. The learner may seek additional information while looking for a solution or testing a hypothesis, but the content of instructional material is meaningful in the context of the problem. This learning process unfolds itself during one's life experience. Therefore, such learning by definition is lifelong, self-directed, situated in the context of one's life experience, and highly independent. Implications of learning theories for the dynamic theory of distance education, behaviorism, cognitivism, and constructivism suggests a continuum that ranges from objective-based teaching to exploratory learning. On the objective end of the continuum, the learner is a novice in need of direct instruction to begin forming schema for new knowledge domains. and to connect new concepts to the ones he or she has already acquired. In this case, it is hypothesized that structure is high and dialogue is low. The learner requires direct instruction and shows low activity to keep the dialogue low and structure high. As the learner develops new schemata and can relate them to prior knowledge, he or she gains the confidence to engage in independent exploration of the new knowledge domain, forms his or her own mini-hypotheses, tests them, and observes the outcomes. Over a period of time, as the teaching-learning process unfolds, for example, in a telelesson or a course of study comprised of several telelessons, it is hypothesized that dialogue will increase and structure decreases as the novice learner approaches mastery and expertise. The instructor, therefore, becomes more of a manager of instruction than the purveyor of information. Eventually, as the learner attains more expertise, the learner and the instructor become collaborators and the instructional system gains equilibrium. At this point, the teaching-learning process may terminate or may continue as a collegial relationship. These hypotheses, however, only explain the relationship of the instructor and the learner, but do not shed much light on learner-learner interaction or learner-subject interaction. We turn our attention to these two matters now. In what seems to be an extension of a biological, psychological theory of connectionism to a social theory of connectionism, Vygotsky proposed the concept of the zone of proximal development. Woolfolk, in describing Vygotsky's idea, said the zone of proximal development is the area where the child cannot solve a problem alone but can be successful under adult guidance or in collaboration with a more advanced peer. For Vygotsky, social interaction was more than a method of teaching. It was the origin